Hi everyone, welcome back. Today we're solving count squared sum triples. So the problem is pretty straightforward. It tells us that a square triple of A, B, C is a triple where these three variables can satisfy the Pythagorean theorem equation, so A squared plus B squared equals C squared. And given whatever input integer that we have, we want to return a number of square triples that can satisfy the Pythagorean theorem equation from 1 to n. So if we look at these two examples, for example 1, we will return 2 because we can have 3 as A, 4 as B, or 4 as A and 3 as B and 5 as C. And for example 2, we can also have these two pairs, and then we can do 6 and 8 or 8 and 6 and have 10 as C. So that's why we return 4. So now that we have seen some examples, let's get to how we can solve this problem. So one way that we can solve this problem is we can check all the pairs. So we can loop through all the possible variables for A, and then within each A, we can loop through all the possible variables of B. And then we will plug in the formula to find out our C, and we will check if C squared is equal to A squared or B squared. If it is, we can increment result by 1 and then return result. If we solve it this way, it will take about O of n squared time, where n is the input n, because we will have to loop through A, and within each A, we will have to loop through all the B's, which will take n time again, so that's why it's n squared. So there's another way to solve it more efficiently, and we can go over that way right now. Now the more efficient way to solve it is we can use the Euclid's formula. And I know most of us are not familiar with the Euclid's formula, so I'll go over real quick. So in Pythagorean theorem, it tells us that C squared is equal to A squared plus B squared. Now Euclid's formula tells us that for all integers x and y, where x is bigger than y and y is bigger than 0, A can equal to x squared minus y squared, B can equal to 2 times x times y, and C will equal to A squared plus B squared. If you guys are curious and want to play around, I can leave a link below, but on Wikipedia, if you search the Euclid's formula for Pythagorean theorem, you should be able to find this calculator, and as you can see, as long as y is greater than 0 and less than x, there will be a, B, and C that can satisfy it. Now also, whenever there's a triple, every multiple of that triple will also satisfy a Pythagorean theorem equation. So if you look at 3, 4, 5, we know that can form a triangle, but if we multiply each side by 2, 6, 8, 10, that will also be valid. If we multiply by 3, that will be valid. We multiply by 4, that will also be valid. And for the sake of solving this problem, we want to be able to calculate it all at once. So what we will do is we will do 2 times n floor division by C. So n would be the input and C would be the base C. So it would be like, for example, for this one, C is 5, and if n is 5, then we will just do 2 times 1. Now if it's 10, then we will do 10 divided by 5, and 2 times 2 is equal to 4. So if n is 10, then we will just calculate and multiply and add 4 at once rather than having to come to this one. Now if we get to this one, how can we avoid not performing this computation? Well, I don't know how this is true or how people discovered this, but this is what I said on the internet. A triple is primitive if and only if x and y are co-prime and x and y have an odd difference. So this would be how the algorithm looks like. We will iterate x from 2 to the square root of n. We don't need to get to n, but only the square root of n. And for y, we will iterate for everything from 1 to x. And by the way, this is just a rough sketch, but for this for loop, we will look at the square root of n, and for this for loop, we will not look at x, so it will just be from 1 to x minus 1. So x starts at 2 because x needs to be greater than y, and y needs to be greater than 0. So that's why y starts at 1. And we will check if the triplet is not primitive. So if it's not primitive, it will either have an even difference or x and y will not be co-prime. And next, we will check if C is greater than n. If it's greater than n, then we can just skip it, because if C is greater than the input number, then there's no point of calculating it. I mean, we don't have to skip it, because n divided by C will floor to 0, and it will just add 0. But for the sake of time, we can just skip it if C is greater than n. And if these two are both false, then we can add this to result. 2 times n floor division by C. So let's go over this example real quick. So first we'll look at x equal to 2, y equal to 1. The triplet is primitive, and C is not greater than n, so we can add 4 to result, because 2 times 10 divided by 5, which is 2 times 2, is equal to 4. And if you're wondering, these are the 4 triplets that we are adding. Now we will look at x is equal to 3 and y is equal to 1. And this will not be a primitive triplet because 3 minus 1, it does have an even difference. So we will skip this one. And now we will look at x is equal to 3 and y is equal to 2. And as you can see, c is greater than n, so we can skip it. Now we will loop through x to 4. And we will look at 1, 2, and 3. But for the sake of time, we will just skip it and tell you guys that it will not change the result because we will not find any new triplets. And we can return 4 as our result. So the time complexity would be O of n log n, because from 2 to square root of n would take square root of n time. This for loop will also take square root of n time. So if we multiply square root by square root, it would just be O of n. And we need to check if the triplet is not primitive. And because of this coprime thing, we will have to check for the greatest common divisor of x and y, and that will take log n time. So that's why it's O of n log n. And the space complexity would be O of 1 because the space that we use will not depend on the inputs of this problem. So now let's get to the coding part. So first we can initialize result to 0, and then we will loop through x. So x, we will start from 2 and all the way to the square root of n, and we will floor it with int plus 1 because we will look at the square root of n, and then we will look at y. It will be from 1 to x, so for y in range 1 to x. And now we will check if it is not a primitive or a primitive, and we will check if the difference is even or if the greatest common divisor between x and y is not equal to 1. If that's the case, then we will just skip, so we can just write continue. Now we can calculate c. It will be x squared plus y squared. And if c is greater than n, then we can skip also. If not, then we can add 2 times n for division by c to the result. And now we can return the result. Let's see if it works. Okay, perfect. Hope this was helpful. Thank you all for watching. If you have any other questions or comments, feel free to leave them in the comment section, and I hope to see you all again soon.